Hi. This video is part of a series in which I learn about programming a retro video game on a Commodore 64 in assembly. The code I'm using is from the game that you see right now. It's called Supernatural and it's written by Georg Rottensteiner. You may also know it as Guns and Ghosts. This is not a tutorial, just me learning game programming. Enjoy the video. Okay, welcome to step 2 of Supernatural. Actually, I wanted to revisit step 1 in Georg's series. The original series there is a step 1b, which goes a little bit further into the code that we saw before, and I wanted to sort of readdress a couple of the things that we saw in the first part. First of all, I wanted to correct, or rather expand on what I said about the labels being calculated automatically. You know, where the editor could help the programmer to calculate between hexadecimal values and decimal values of register addresses. It does that, but only after you've done a build. If I press build, the assembler will make a symbol table of all. See, this is what I wanted to show in my first video. If I put my my cursor on a symbol, it will show me the name, it will show me the decimal and the hexadecimal values. So in that sense, with the correct help of the editor, I can use either form of a number or a register that I want, because I can go into the code, I point at this one and say, oh, it's DO20, the border color. Okay. I have also made some adjustments to the last code just to help me explain a few things. And that is mainly about the way that the memory is set up, because that is, although I don't understand the reasoning behind all of his choices, let's see if I did increase the font size, so it's a little bit. There's a P has, oh, that's probably a label. It's not completely fault free, this editor, by the way, because I can't scroll to the right, although I know that there's more text here. So if I cursor to the right, there is something. Now, let's have a look at this. The last time, yes, we turned off the sprites, DO15, that's no big secret. Then we went on to tell the VIC chip at which part of the memory it would be looking. Now again, the reasoning behind why this particular location is chosen, I guess, you know, it's all at the end of memory, so we can have all our program data and our program code sit at the start of the memory space, and then have our character data at the end. It's a matter of organization or preference or whatever. Now the way this is controlled is to write a number to DO18 or 53272. I've written that number as a binary representation because it is easier to explain. Because, here we go, bits 1 to 3, and remember I always count from 0, so this is bit 0, and this is 1, and so on. So bits 1 to 3, that's these 3 boys, select the character dot data location. This means that the VIC, whenever you tell it to write a character to the screen, it's going to look here for what that character is supposed to look like, right? Because you can change the shape of the characters. Now, how does this work? If we look at the entire nibble, and a nibble is half a byte, then that says 1100, which is 12 in decimal. Then we calculate the location of where within the 16K block that the VIC always sees, regardless of where that is in the 64K that the Commodore has, you calculate the location by multiplying the nibble, which is 12, by 1K, because it goes in 1K increments, which is this number. Alternatively, you could say, well, let's just look at the value of these 3 bits, which would be 6, which is logical because it's actually shifted to the right once, which is division by 2, but I digress. 12 times 1K is this number. We already know, because that's like the next command, that the VIC is going to look at a 16K portion of the memory that starts at this location. So we add this, what we just calculated, to the location that the VIC is looking at, giving us this absolute address. So that is the address where, what have I done now? That is the address, let's get it in view, where the VIC is going to look for character data. So any data that we write to this place, and that's actually the next 2K, I think so, is going to be character data. Okay, so remember that. Bits 4 to 7, which is also important because in the program, remember that in the program, I scrolled down. Let's not do that yet. We increase a memory location inside the game loop to show like a character moving in the top left corner. And wondering where does that number come from? Because that number is, I'm scrolling up now, that number is this. If I scroll, screen character, and it was this number, and I didn't understand why it was that number, because normally when you turn the Commodore on, the screen character memory is at this location. Oh, sorry, at this location. Excuse me. Now moving the VIC's base address to this would lead to the new screen memory location to be this. But it's not, because it's this. Why is that? I didn't get it until I looked at the Mapping the Commodore 64 book, which said, well, nibbles 4 to 7 say where the video matrix, where the screen data goes. Now, this number boils down to 3. You multiply it by 1K again, you get this number, which, lo and behold, is that, COO. So the screen location, again, is the new VIC's base address, plus COO means this, which is that number. So it makes sense, actually. We figured it out. Now bits, after we've done that, we actually manipulate the first 2 bits, bits 0 and 1 of CIA2's port A, which controls the actual location that the VIC looks at. Just remember that setting 00 to these bits means that we look at this area of the memory. But we already knew that because we're already using that right here. And then the main game loop starts. Da-da-da, we've already looked at that. Now, it's smart to do this now. I'm gonna save it anyway. But what I'm gonna do is I'm gonna I'm going to change this to the version of step 2. I'm going to copy the code of step 2. I have it in my editor. Now, I'm going to lose all my remarks. That's one thing that I'm not happy with. That I'm going to lose all my remarks, and I haven't figured out a way to keep my code. What I'm going to do is this. I'm going to file, I'm going to save mine as jmainc, as in commented .asm. I'm going to save that. Right? I'm going to have a little look at whether that's actually happened now. Please bear with me for a second while I check. Yeah. Okay, and the editor doesn't automatically switch to that. It stays in my original file. Fine. Now I pick up the code from the other, from step 2. I say paste. All the code is changed. We go to the top of the code. Now, of course, all my work has been undone. I've added some remarks already, but my original remarks were undone. That's just the way it goes, I suppose. So, look, Georg has started using labels as well. Before I continue, I should also make sure that, because in step 2 he adds a number of files, mainly a character set. I'm gonna copy that in as well. You can't see that, but I can, and I'm doing it off screen here because if I didn't do it, my code here wouldn't compile. So I'm going to save this. I'm going to build just for... Did we have output? Yes, we did. Okay. Georg has started using labels as well. Thank you very much. Now, he's using parameters, and I actually like seeing this, because this means that he's going to write subroutines, and if you write a subroutine, you want to pass parameters to it, but assembly doesn't have parameters. I mean, it's like a first level language, so no fancy function structures. So you have to have a piece in memory where you keep your parameters, and he has defined 5 parameters. The thing is, where do you keep them? Now, he keeps them in 0 page, which is the first page of memory in the Commodore 64, which is filled with memory locations that are used by BASIC. But we don't use BASIC. We actually switch it out of memory, which means that we can use many of the places. And he's just picked a couple. 3, 4, 5, 6, 7. These are memory locations that are very easily accessible, which means very quickly, and they are all 1 byte wide. Then there are 0 page pointers. Remember that each memory location has a 16-bit address. Each address holds an 8-bit number, but the way to address it is 16 bits. So 16 bits being 2 bytes, if we want to point at a memory location, we are going to need 2 bytes for each memory location, which can function as a pointer. If we do indexed addressing or indirect addressing, I should say, we need memory locations to store addresses. So 17 and 18 are one set, 19 and 20 are one set, 21, 22, 23, 24. All hexadecimal values, all used by BASIC for some string functions or whatever that we're not going to use while we are running our program. Now, screen character location hasn't changed. We have a screen color now, which is at this location. The color RAM is always at this location. It doesn't change. This hasn't changed. this hasn't changed. I mean, of course, I've copied it back, so we're back to this again. You know, it's the character set and the Vic Bank. That's what we've just looked at, but now in decimal code. So what are we going to do? We're going to do a thing here. We have our own character set. Georg has defined a character set. Our own. Oh, I've scrolled down. I hate when people who make videos do that when they don't say what they're doing. I just scrolled down and scrolled back up again. Why did I do that? Because I wanted to show you that at the bottom, and I'm scrolling down, at the bottom we include the binary version of that file, and we include it at this location, car set. You can also see that the editor tells us at which memory address that appears to sit. Right? So that sits right there at 08AB. Scrolling back up. Now, we've included the code in our program. What we do now is we copy it to the correct location for the VIC to recognize it as our new character set. So we have to copy memory. We actually have to copy 2K of memory. Now, this is going to be interesting as well, because straight out of the gate, without any further explanation, he starts messing with the memory setup of the Commodore, which is controlled by memory location 1. If you have a Commodore 64, if you poke an arbitrary value into this memory location, the chances that your Commodore will crash is quite large. So this command says cancel all interrupts. This is the setting the interrupt flag. What we're going to do is we're going to switch out the kernel for a little while, which means that if we do anything during that time, things are going to go wrong. If we switch out the kernel and we do something that the Commodore needs, you know, the basic or whatever needs access to the kernel, and it's not there, it's going to crash, because it's just going to jump to a memory location and it's got nothing there because it's now RAM there. So what we do is we save the original value, and at the end we just restore it to that, right? And in the meantime, there's no interrupts, but we have a little bit of time to do something that we want to do, and that is do this. We load this value, and I just looked this up, but of course I didn't remember it correctly. But right, bits 0, 1, and 2, which are these are the ones that control the memory setup. The first bit is low RAM, which means that we want let me see correct. This is going to turn the basic ROM off, so it's going to switch out the ROM and put RAM in that place. Bit 1 is high RAM, which is the kernel, so we're choosing RAM instead of the kernel. And this one, it says that we want the character generator ROM present. That bit of memory is a bit complicated, because I'll try and show you if I have the picture ready. Where is it? Of course I can't find it now. Underneath all the there it is. There it is. There. If we look at this, we're talking about the piece of memory that is here. Now there's RAM underneath, but there's character ROM there, and there's also I/O. There is even, and if we take a look at this picture, this is the same bit of memory, RAM, character generator, I/O, and color RAM, all in the same location in memory. So setting 0 here means that we have the character ROM in that place. The funny thing is that if we read from addresses in this place, we get the ROM values. If you write there, nothing appears to change, but the values are written into this RAM location. So there is RAM there, actually. Right, confused yet? I am. So that's what we do. We pick RAM where we can. We store that value in A1, and from that moment on, from this moment on, there's just RAM and the character generator ROM. So what we do here is we remember this car set. This is the address that points to our new character set. We store the low. I'm not going to explain this in depth, but addresses are stored in memory low, high, right? So 0 page pointer 1 was 17. That memory location, I'll write it out. Imagine that the character. I am going to explain it in depth. Who cares? It's clear for me as well. Imagine an address A4 F5, just F5. Any old address. It is 2 bytes. It is a low section, F5. This is the low part, the least significant part, and this is the high part, A4, the most significant part. Right? This is actually A400 plus, well, you could write 00F5, right? Now, what we do, if you want to store this as a pointer in memory, location 17 would get F5, and location 18 would get A4. So the low part, the least significant part, comes first, and the most significant part comes last, right? So that's what that does. I'm going to have to... I'll remove this again. So that's what happens here. The least significant part is stored in the first 0 page pointer address, and the most significant part in the one that comes after that. You know, the +1 means that. So basically all we've done is 0 page pointer 1 is now pointing to our character set. And we jump to a subroutine. Jump subroutine, copy character set. There we go. Where I'm scrolling down. Well, let's not do that. Let's quickly look at what the rest of the program does. It restores the memory. There's really, now that I think about it, there's no need to do that. At this point, we could have just copied whatever is here to the new location. No problem, without having to shut off basic. Anyway, we clear the interrupt flag. You know, we restore the situation, and we clear the interrupt flag, and everything is back to normal. Of course, switching out the kernel is important because we've just copied our character set to the kernel location. Yeah, that's what we've done. Then we write the word hello to the screen, and we give it some color, and then the main game loop starts again. But this is pretty important. Copy character set. Now this is this is our wait frame code. This is a new function that we haven't seen yet. We set a target address. See, we use another of the 0 page pointers. This time we use location 2, which is 19 and 20. and we set it to F000. If you remember, just now we said that the Vic would look there for our new character shapes. And it begins. We initialize, we set X to 0, we set Y to 0, we set A to 0, and store a parameter. We use a parameter here, just a variable actually. It's not, the parameter is not used as a parameter, but as a variable. We store 0 in it. And here it goes. We use indirect indexed addressing, so the address that is stored at this location is read, and Y is added to it. And we load what is there. Now, this contained the address that was pointing at our character set, and we add 0. We add 0 because Y was just set to 0, and we load that value. We store that value in the address that is stored here. So we copy it from here to here. Bang. Now we do that 8 bytes, and then we test whether or not we are at a page boundary. Of course, we are going to copy like 2048 bytes. Now normally in a normal programming language I would write a loop that says, well, you know, just repeat this 2048 times and get your work done. But in assembly, in this computer, we don't have a counter that can go up to 2048. The maximum counter value that we have is 256. Actually, it's 255, but we have 0 to 255, which is 256 different values. So we test Y for flipping over to 0. What happens if an 8 bit value can have values that range from 0 to FF? That is 0 to 255. If Y equals 255 and you add 1, I'm tutorialing again. If you add 1, it goes back to 0. That's basically, it just flips over. So we test for that. If we reach our page boundary, 256 bytes is a page, we just call that a page, we increase the high parts of our 0 page pointers, which makes sense. Now, at the end of our memory, there's a couple of pointers that we don't want to mess with. And because we've chosen for the Vic to look at the last part of memory, we want to leave the last 16 bytes. Yeah, the last 16 bytes, we want to leave them alone. So after we've done 8 times 256, or 7 times basically, we use this parameter to count the last, you know, to check for the last page. If we are at the last page, we just want to do 254 bytes because we want to leave the last 16 bytes alone. And when that happens, we just say character set done, and we jump back out of the routine. This is actually kind of a clever routine. It took me a little while to understand what was happening here. Basically, we're letting Y loop around. We just increase it here, but we don't do anything. Every 8 bytes, we check whether we've reached the boundary. If so, we increase it. If not, we keep this extra counter. And when we've done 8 times 254 bytes, you will know that that is almost 2K. If we did 8 times 256 bytes, we would have done 2K. but we stop just before that. This is actually very clever. This shows to me that, you know, I've written routines like this. I did them differently. This is better. I am impressed. Want to see what it does? It compiles without error. Shall it run without error? Yes, it says hello. I'm just not getting any color. See that? It's just not, there's no color going on. What did he... Oh, wait a minute. He chooses the same color. We can make a different color. Build and run. Yeah, all different colors. And oh, look at what we have. We now have a brick wall because we have our own character set. Yes. Yes, we do. So that is it for part 2. I cannot help tutorialing a little bit, but it does sort of help me, but I have to stop myself at certain points so that I'm scrolling down at certain points because I can go on, and before you know it, I'm giving courses. I do like the way, by the way, that I can, you know, I see that I can actually use string, you know, characters. Okay, well, that's it. That's the end of the video. Again, thanks for watching. Leave a comment, and I'll see you next time.